Hello, everyone. This is the final project for machine learning for product managers provided by Duke University. In this presentation, we're going to talk about these topics: evaluating the potential opportunity, understanding the business problem using Christian method, validation of the solution plan, machine learning design decisions, potential threats in production, and conclusion. First, we'll start with the evaluating the opportunity. The project we're talking about, or the opportunity we're talking about, is the AI baked backed in-house device monitoring system. So the problem here is basically taking tracking the health of the in-house appliances or the devices running in a house to make it a home in United States. The major problem what homeowners face is the application and appliances or the devices fail when they need that device or the appliances the most. For example, the AC unit breaks down during summer, or the heater breaks down during the winter. So most of the time, the homeowners pays a premium for the emergency fixes. So that's the problem we are talking here. Who does this matter? Homeowners would care if we can preempt the failure of a device or appliances and save the cost for the homeowner. And the last minute replacement cost, which normally goes high because it is an emergency fix, which you need to do to make the home livable. How a ML model can solve the problem. So machine learning system would help to provide the to prediction and anomaly detection for the devices that are attached to the home and predict the future failure or probable end of life for a device. This could be very attractive for the homeowners as they can save money and costly last minute service call or emergency repairs. Next, we're going to talk about the CRISP-DM process. First is in the process, the CRISP-DM process. The first step is to understand the business problem. Then we have to understand the data, and then we have to prepare the data. Then ultimately model the data and evaluate that model what we have just created based on the data. And then we use then the next process is the deployment, and then in the deployment, after the deployment, we have to go through the customer feedback, see how our model is doing. And then ultimately it goes through the iterative process to ultimately fine tuning, and it is learning itself all the time based on the customer feedback. Now, using this CRISP-DM method, let's evaluate our business problem, the business opportunity. Here, the target customers are the homeowners. Here, the problem statement is the homeowners spend a considerable amount of premium price fixing or replacing a critical device in the house, as the device is either needed to be fixed or replaced urgently for the comfortable living in the house. Why it matters? Most of the time, a particular device or devices breaks down when the homeowner need it the most. As we talked about, most of the time the heater breaks during winter, AC unit breaks during summer, or some pump stops working during the rainy season. So it becomes a huge problem for the homeowner. How it is solved today, homeowners just wait for the device to breaks down or and stop working and call the emergency providers to fix the issue immediately. Sometimes it is over the weekend or it is on the holidays, or they can just replace the device even if there is some life left in the device. And so gap in the current state. There is no predictive system available to preempt the device failure as of now. Next topic is CRISP-DM define the success. Expected impact is the cost saving for the homeowners and the rental property owners for the last minute service calls, and that will help the homeowner to properly plan for the larger expenses due to replacement of a critical device. Um, some constraints in the process is the data collection from the different devices, as the different devices are being made by different manufacturers. So the data collected by all those devices will be in different format, different parameters they would be collecting. Now, for our purpose, we need to normalize the data so that the data can be ingested into the ML model, and ML model can provide the anomalies in all the data. Matrix, what we want to consider here is these are the outcome versus output. So outcome would be the peace of mind for the homeowners, so that they don't have to think about some critical device failing during the peak summer or peak winter or peak rainy season. Output would be the mean square error of the bad outcome for the early warning system or early warning failures. Next is CRISTIAM define factors. We are defining the factors which is going to affect the model. Um, so first is the time. So time of the year, as we are talking about the summer, winter, and then the weather, snow, rain, hot summer, humidity, locality. Locality also plays an important factor into the ML model because of the house location or the rental property. It could be situated at low-lying land or rain-prone area or heavy winter or humidity, which might affect the device performances. Seasonality, heavy rain, heavy snow, etc., which we have to consider as well while as we are designing the system. Now the solution validation plan. So as we are defining a machine learning model, we need to make sure that we have a validation plan for the machine learning model. Machine learning model, we have to always train before we can use that. There is no rule set by the application programming. It is the data which is basically feeding the information into the model, and model will learn from the data. So in order to do that, we need to set aside a considerable amount of test data or training data. So the plan is to divide up or keep 70% of the data as training data and 20% for validation data, and then 10% as a test data set. Training data set to be used to properly train the data set and select the relevant features, which will help to properly label and the data while feeding the data to the model. Now, the data collection and cleaning. Data collection and cleaning could be a major problem here. The reason is there are different devices from different manufacturers which are in the home, and data collection from all the devices which you need to collect and clean the data, kind of normalize the data, and ultimately the data collection mechanism has to be continuously done from all the devices as new devices come online or new devices being added, or homeowners just change the appliance from one manufacturer to the another manufacturer. So that fine tuning has to be done continuously. Defining the performance metrics, so accuracy of the prediction will be 95% correct correlation to the actual failure. Sign-ups by the homeowners for the services that indicates the likability and usability of service provided. Provided solutions should be up to date with the homeowner appliances and electronics equipped new technologies. As the new technologies become available and that gets integrated into the appliances, we need to make sure that we collect that data so that homeowners has the data, or we can predict that kind of device failure based on new technology, based on the data provided by the new technologies. Now, establishing the baseline and the validation, initial performance should match with the existing solution. There may not be any existing solution, but at least we can some benchmark some of the devices lifetime, and based on that, we can evaluate the prediction from the machine learning model. The second is benchmarking for validations and periodic manual evaluation of the results. This is very important. The reason is we cannot just have the machine learning model running and forget about it, because machine learning model needs a continuous observations or training and making sure that it is staying in course It is not hallucinating or deviating from the norm too much. Otherwise, the predictions which we're going to get from the machine learning model, it is not going to be accurate. Next is the machine learning system design decisions. One, so there are a number of design decisions we need to make in order to make sure our machine learning model goes to production and it can be used by the actual customers. The first design decisions is the cloud versus edge. As system can run over the internet, the system can run on the cloud and deliver the output to the homeowner's computer. We don't need a very high computing system in this case, as the data analysis can happen after the fact, and cloud can be utilized, and then the result can be sent to the homeowner's computer. So we don't need something to be running on all the time on homeowner's phone or laptop so that it can give immediate result. But here we can consider as it's a cloud-based system. Offline versus online learning. Here, as we are doing it, offline learning would be recommended for the data as data to be ingested in the offline mode. The reason is the data has first to be normalized and then data can be ingested. Due to the diverse nature of the data collection, data preparation would take some time to prepare the data before it can be ingested. Batch prediction versus online prediction. Batch prediction would be okay for predicting the device failures. Future improvement can be achieved via a hybrid mechanism, so that the prediction can be made online with online learning and online prediction so that the urgent service need can be predicted. Next design decisions is based on the technology to be used. Machine learning technology is the cost versus time needed to build the solution. That is a major design decisions which we need to take because there are so many software, so many ML model available in the market. It is open source. We need to decide whether we are gonna go ahead with the open source ML libraries or commercially used machine learning libraries. Building machine learning libraries could be from scratch, could be very expensive, and we may not have the whole expertise to create a machine learning model which can give us the accurate results. Other consideration is the programming language and the modeling toolkits and the APIs and the code base, how to store and how to retrieve and all that all that decisions we need to make when we go into the actual programming, actually creating the solution. The potential risk in production for machine learning failure can lead to an irreversible impact on the future of the business that uses the machine learning system. Data drift is a major problem for machine learning or ML AI system, which can actually make the software or break the whole system or the application which we're trying to create for the software. It can and the output can decay over time due to changes in the environmental and driving factors, availability of the new data due to advancement in technology or advanced home devices. The data can drift, and because of that, the machine learning module cannot correctly predict the failure for that particular device. So we need to be vigilant about what are we doing, and as the new technologies come in and new devices becomes available, that data has to be normalized and should be properly managed so that the data can be ingested into the AI ML model. Training skews. The trained we are when we are training the data model, we may be training the model with the clean data, and that could be a problem when it goes to the production and it actually is seeing the actual raw data. Um, Concept drift. ML AI can fail due to shift in the relationship with input parameters over the course of time, and ultimately it will generate an unreliable output. Next is the conclusion. So in conclusion, AI/ML backed home monitoring system will improve the quality of the life of the homeowners or the rental property owners by predicting or doing preventive maintenance. In exercise, Christian process provides the approach to developing a structured solution. Validation plan provides the framework to evaluate and compare the model's performance. Business objective drives the ML design decision help to maintain the expected ROI from the project. ML model needs to be monitored and output measured so that the model remains relevant and does not hallucinate based on the bad data which you're going to get from production. So ultimately, this gives a very good approach to think about a machine learning AI/ML model, AI/ML problem or business opportunity, and how we can design that AI/ML solution and productionize or socialize that information and that application and get it to the actual customer to use. Thank you very much. Take care.